All right, guys, here we have page 33. This is Boyle and Charles. Okay, so these are the first two gas laws we're going to learn today. It involves a little bit of math, but I think you'll find that it's a lot easier than stoichiometry. This is actually like one of my favorite units is gases because it's math, but it's simple and it's fun. It's just a good time. All right, so Boyle and Charles. So the first one we're going to talk about is Boyle's law. Boyle's law. Okay, so at a constant temperature, the absolute pressure and a volume of a gas are inversely proportional. We talked about this on our notes last time. Inversely proportional. Hope I spelled that right. So that means when your pressure goes up, your volume goes down, and vice versa, okay? They're inversely proportional. And here you have a nice little picture showing you. It says pulling up. If you have this little like piston thing here, it says pulling up increases the volume, but it decreases the pressure, right? Because when you increase the volume, there's going to be less collisions. But if you push it down, it decreases the volume, so there's less space. So the volume's decreased, but there's a lot more pressure because there's a lot more collisions. And I love the way this is phrased. It says, in the smaller space, the particles suffer more collisions with the walls of the container. I love that. They suffer more collisions with the walls of the container. It is this that is measured as the pressure exerted by a gas. So that just reminds us that the more collisions we have, the more pressure there is. Okay, so let's take our highlighter and put a big box around this. This is our formula for Boyle's law. So whenever we're given an original pressure and volume and asked to find another pressure or another volume, this is the formula we're going to use. Now let's remind ourselves what units we could encounter for pressure and volume. For pressure, what are some of the units we know for pressure? We know atmospheres. So write this down for pressure. We know kPa, which stands for kilopascals. We know PSI, which stands for pounds per square inch. You see this one a lot in like the tires of your car. And then mmHg, that stands for millimeters of mercury. And remember, that's the same one as torr, because Torricelli was a scientist in Italy who discovered the barometer. And a barometer is basically like this big, he's the guy who discovered you could measure atmospheric pressure. It's like this big tube with mercury in it. And it has like this like pool of mercury down below it. And he basically figured out that as the atmospheric pressure pushes down on this mercury, the mercury in the tube goes up and down. So that's a basic barometer. And he used mercury because it's a very dense liquid. It's before they knew that mercury was very poisonous. So he was able to use, and he noticed that at sea level, it was literally 760 millimeters of mercury high. So anyway, so he's the guy who discovered the barometer. So he got Torr named after himself, Torricelli. Okay, that's a side note. Volume. What units do we use for volume? Most typically we see liters, we see milliliters, sometimes we'll see centimeters cubed. There are other units out there for volume. Technically you could have liters cubed, technically you could have like a microliter or a deciliter or decimeters cubed, but these are probably the big three that we'll see. Okay, let's look at an example. It says the air in a syringe has a volume of 25 milliliters when the pressure is 4.38 atmospheres. What will be the volume when the pressure is 0.65 atmospheres? Okay, so it gives you a volume and a pressure. Then it gives you another pressure. So this is our first volume. Okay, so this would be our V1. This is our second volume, this is our first pressure. This is P1 because I know that milliliters means volume and I know that atmospheres means pressure. I also can read the words volume and pressure next to it. Okay. It says, what will be the volume? So it wants to know, hey, what's the new volume going to be? So it's looking for V2. It's saying, hey, what's the new volume going to be when the pressure is 0.65 atmospheres? This would be our P2. Okay. That's the hardest part, is just being able to read the problem and label which variable goes with which. Now that we've done that, we just plug and chug. So I'm going to write the equation just so I remember it. P1V1 equals P2V2. P1 is 4.38 atmospheres. V1 is 25 milliliters. And we don't need to convert to liters for these gas law problems yet until we get to the ideal gas law. For now, These are fine, just the way they are, as long as it's the same on both sides. Like if this was atmospheres and this was kPa, they would need to be the same. But if your pressure units on each side are the same and your volume units are on each side are the same, that's fine. Okay, pressure P2 is my 0.65 atmospheres. And my V2, that's my variable. That's like my X. You can call it X if you want. I'm just going to label it V2. That's my variable. Okay, so now I need to get volume V2 by itself. So I'm going to divide by the 0.65 atmospheres to get rid of it. Do that to both sides. Get out my calculator. And in my calculator, I'm going to put 4.38 times 25, enter, divided by 0.65, and I get this, 1.64. So I'm going to write out my unrounded one. V2 is equal to 168.4615. And then how many sig figs do I need? Let's see, this has 3 sig figs, this has 3 sig figs, this only has 2 sig figs because leading zeros don't count. How do I round that to 2 sig figs? I'm going to have to round it to 170. And what are my units going to be? Well, I'm looking for volume. If my first volume was in milliliters, then this one has to be in milliliters. Another way you can tell this has to be in milliliters is because your atmosphere is canceled and you're left with milliliters. Okay? Okay, cool. Let's do Charles' law next. Oh, also, why is it called Boyle's law? Because a guy named Boyle invented it. Can you imagine if your name was Boyle? Yeah, it happens. So that's why it's called Boyle's law. Charles' law was named after a dude of the name Charles. So all these are named after scientists. Okay, so Charles' law, also known as the law of volumes. When pressure is held constant, the temperature and volume of a gas are directly related. We talked about that last lecture. Okay, so that means when temperature goes up, volume goes up. They're directly related. And remember, whenever, ever we are plugging temperature into a gas law equation, it must be in Kelvin. Only Kelvin is allowed inside any gas law equation when we're dealing with temperature, okay? And here is a nice little visual for you. You've got these particles here, and then you heat it up. Look, the flame gets bigger, so that represents that more heat is being added, the temperature is increasing. Okay, so now this little piston moved up and the volume increased, okay? So here's an example. It says calculate the decrease in temperature. Let me scoot that down. Calculate the decrease in temperature when 2 liters at 20 degrees Celsius is compressed to 1 liter. So it's basically saying, hey, we had 2 liters, we're going to compress it down to 1 liter. What's the new temperature going to be, basically? Assuming everything else is held constant. So this is liters, so this must be volume. This is degrees Celsius, so this must be T1, that's our temperature. And then it's going to be compressed down to this, so this is liters, so this is going to be V1. So let's remind ourselves, volume, remember, it can be liters, milliliters, centimeters. Temperature is probably going to be in degrees Celsius or in Kelvin. Okay, let's write those down so we know when we go back and look at our notes, we know kind of what units go with which variable. Okay, so let's write our equation, V1 over T1 equals V2 over T2. I'm going to make you guys write the equation when you do the problems on the back every time, just to really get them into your brain, because you have to have these memorized for comps and stuff. Okay. Okay, so V1 is 2.00 liters over T1. Uh-oh, this is in Celsius. What did I say? Has to be in Kelvin. So how do I convert to Kelvin? I need to add 273. So write that down. So I'm going to go 273 plus 20 is 293. So this is 293 Kelvin. So I'm going to plug this in Kelvin. So my T1 is 293 Kelvin. My V1 is 1.00 liters. And then what am I looking for? So I must be looking for V2. Or sorry, T2. So I'm looking for T2. Okay, so now we need to solve this. I'll give you guys a little hint. So what you're going to do is cross multiply and divide. but I'll give you a little like shortcut hinty hint here. This is how I solve, because we're going to see a lot of problems like this that are set up in a proportion like this. Shortcut time. Find the two numbers that are across from each other. So not the variable, but the two numbers that are across from each other. You're going to multiply those. You're going to cross multiply those. And then you're going to divide by whatever's left over. So I used to, for a brief time in my life, I taught 6th grade math, and this is what I taught the 6th grade math students that I used to teach is I called it the cross and box method. So I found the two that are across from each other, multiply the things that are across from each other, and then divide by the box, divide by whatever's left over, divide by the box, and that will tell you what T2 equals. So let's try it. Cross multiply and divide, that's all we're doing. So 293 times 1, which is obviously going to be itself, and then divide by the box, divide by 2, divided by 2. And I get 146.5. So T2 is equal to 146.5 Kelvin. Now, be careful. Read what the question asks you. The question asks, calculate the decrease in temperature. Does it say calculate the final temperature? No, it says calculate the decrease in temperature, basically saying like, what was the change in temperature? How much did the temperature change? So the decrease in temperature, do you guys know what that delta means? It means change in. So the change in temperature is going to be your final temperature minus your initial temperature. Okay, so, or really, I mean, it doesn't really matter either way because, I mean, you don't have to worry about negatives so much because I guess you could think of it this way and then this way because we're looking for the change in temperature, like how much did it go down? Okay, so we're gonna do our 293 minus our 146.5. And guys, check this out. 293, 146.5. We get 146.5. It was just cut in half. Okay, so it's still going to be 146.5 Kelvin. And then if we round out to 3 sig figs, it's going to be 147 Kelvin. So that's basically how much it went down if you're rounding to correct sig figs. Okay, so that's your decrease in temperature. So make sure you're reading the problem to make sure, is it asking you actually for like T2 or T1 or V1 or whatever, or is it asking you how much did it go down or how much did it go up? Okay, so be careful with that. Okay, now if you look at the back of your paper, this is basically one big U-try you guys are gonna do. And this is what you're gonna submit as your homework. There are 7 problems here. 7 problems, but make sure you're reading the directions. It says you need to write the gas law equation. So write the equation for each one. Write the equation first, and then label each number. Some people like to write it out, like P1 equals blah, 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 T1 equals blah, blah, blah. That's totally fine if you want to do that, or you can do it kind of shorty cut like I did, where I just kind of underline it and write right above it which variable goes with which number. But I need to know like what you're plugging in. So label each variable with each number. And then solve for the unknown. Okay, so just show all your work. Okay, show your work. And I think that is pretty much all I have to say about that. Okay, so go ahead and work on that and then submit it in assignments. Good luck.